Good morning or good afternoon, it's Ms. Bauer here, and today we're going to talk about special right triangles. Now, there are two special right triangles, and that's 45, 45, 90 and 30, 60, 90. What's special about these triangles is that they have this pattern that they follow every single time. And so they have this ratio that they follow. So remember, a ratio is just a fraction, so it'd be like 1 to 2. And then what you do is you follow that pattern. So let's just say that the ratio was 1 to 2. Well, then if you had 3, it would be 3 to 6. Or if you had 5, it would be 5 to 10. And so these special right triangles follow that ratio pattern. So the first special right triangle that we're going to talk about is a 45, 45, 90. Now, if you remember that 45, 45, those are the same, that makes this an isosceles right triangle. So I'm going to add some ticks on here. And the pattern that this follows is that the legs would be your 1 and 1 parts. So the leg would be 1 and the hypotenuse would be root 2. So it follows a pattern of 1, 1, root 2. So if it were 7, it would be 7, 7, 7, root 2. If it were 30, then it would go 30, 30, 30, root 2. And let's say that the hypotenuse was 55, root 2, then your legs would be 55. So that's that pattern rule. 30, 60, 90s are our other special right triangle, and they follow the rule of the shortest leg is 1, the longer leg is root 3, and your hypotenuse is 2. Now, you can tell which side is the shortest and which side is the longest by Hinge Theorem. So if 30 is the smallest number in a 30, 60, 90, then across from the 30 should be your shortest leg, which is 1. Across from the 60 would be your longer leg, which is root 3. And then, as always, our hypotenuse is the biggest side, or 2. So our hypotenuse would be 2. The longer leg would be root 3. And our shorter leg would be 1. Now, because they're ratios, because they always follow these patterns, what's nice is that we can set up a proportion and figure out exactly what everything is. So I do what I like to call the chart method. So the chart method is where I have all of these numbers in the chart, and then I put my numbers in the chart and then cross multiply, I have my proportion, and that's it. So my chart for 45, 45, 90s follows the pattern of 1 root 2. And it doesn't necessarily matter if you put it on the bottom of your chart or the top of your chart. We're all going to end up cross-multiplying anyways. What goes with the 1 is the leg, and what goes with the root 2 is your hypotenuse. So we fill in this chart, and we're going to cross-multiply it out to get our answer. Now, 30, 60, 90s have 3 parts, so our chart's a little bit longer. That's okay. And I always go from smallest to biggest in the chart, which is why I went from the leg to the hypotenuse. And in this one, I'm going to go from the short leg to the long leg to the hypotenuse. And remember, the short leg follows the 1 rule, the long leg follows the rule of root 2, and the hypotenuse, root 3, root 3, and the hypotenuse follows the rule of 2. So the easiest way to solve these problems is to ask yourself, do you have a special right triangle? If yes, which pattern is it going to follow? Fill in your chart and then cross multiply for your unknown. That's it. So let's take a look at this first one. Okay, I can see that it's 45, 45, 90. So I'm going to go ahead and I'm going to go back up here. I'm going to use this chart, the 45, 45, 90 chart. So in the bottom of that chart, I'm going to fill in 1 root 2. And then whatever I have for the leg is going to go there, and whatever I have for the hypotenuse is going to go there. Now, because this is 45, 45, 90, and that's isosceles, I'm going to put ticks on here, which means that I actually already know one of these variables without having to do anything. And that's, remember, if the legs are the same, so P should just equal 7. No solving for that. I can just find that out because the legs, if it's isosceles, the legs should be the same. If that side is 7, then P should equal 7. So down here in my chart, what goes above the 1 is your leg, which we just said was 7. And then the root 2 is the hypotenuse, which I don't know. That would be R. And now I'm going to cross multiply. Now, some people with special right triangles figure these patterns out so fast, and they don't necessarily need to follow the chart and the proportions and all of that, and that's great. But you do need to show some work, and this chart is just a very easy way to show some work. So here's my proportion. 7 over 1 would equal r over root 2, and then I'm just going to cross multiply. So r times 1 would be r, equals 7 times root 2 would be 7 root 2. Remember, in a proportion, I just have a fraction equals a fraction. I cross multiply, and then it tells me r is 7 root 2. I'm done. That's it. I don't have to divide anything out. It works out super nice and neat. So let's take a look at this next one. The number got cut off, but this should be a 10 right here. So let's just add a 10 in right there. Okay, I noticed 45, 45, 90 again. So I'm going to use that same chart that I had before, with 1 and root 2 on the bottom. And you actually don't even have to memorize these charts. We will provide them for you. So 1 and root 2 on the bottom. Okay, now remember, if it's an isosceles right triangle, the legs are the same. So it doesn't matter whether I pick y or whether I pick z. If I find y, I know z. If I know z, I know y. So for this, I'm just going to put a y in there because I think it's easier to draw. And then what is the hypotenuse? Well, it's 10. So I'm going to put that in this spot right here. So now to solve this, here's my fraction equals a fraction. I'm going to go ahead and cross multiply. Y times root 2 would just be y root 2. Equals 1 times 10 would just be 10. But remember that my goal is to get y. I don't want y root 2. I just want y, which means that I'm going to need to divide by root 2 on both sides. So I'm going to go ahead and divide by root 2 on both sides, and that would cancel out, and then it leaves me with y equals 10 over root 2. Now, if you remember from previous videos, you're not allowed to have a radical in the denominator. Remember, we said if it's in simplified radical form, you can't have a radical in the denominator. But the easiest way to get rid of it is we're just going to go ahead and multiply by root 2 on the bottom and root 2 on the top, and it's going to be all good. So remember that I multiply by whatever I have in the denominator that's giving me trouble. So root 2 times root 2 is just going to become 2. Remember, the roots cancel each other out, so now I have 2 in the denominator, because root 2 times root 2 is just 2. And then my numerator is going to be 10 times root 2. 10's out, so it's going to stay out, and root 2's in, so it stays in. So now I've simplified it. I don't have a radical in the bottom anymore. There's just one thing left, and that's look at what's outside and ask yourself, what is 10 divided by 2? Well, 10 divided by 2 is 5, so I'm going to rewrite my answer. I'm going to say that y equals 5 root 2. And back up, well, y was the same as z, so if y equals 5 root 2, then z would equal 5 root 2. That's it. So let's take a look at our next one. Now we have a 30, 60, 90. I need to be a little bit more careful here with this 30, 60, 90. There's a little bit more that's going to go on the bottom of the chart. So if I just scroll back up, so the bottom of the chart is 1 root 3, 2. So 1 root 3, 2 goes on the bottom. And now I'm going to go from smallest to biggest in the triangle. So remember, small opposite small. So if 30 is my smallest angle, then 2 is the shortest side, so that should go first. I know my hypotenuse goes last, so that's across from the box. That means T goes in the last spot, which means that S would go right here. Okay, now where I have to be careful is the fact that I have multiple variables, which means that I'm actually going to have 2 proportions. But I'm going to use the one that has a number on top and a number on bottom twice. So my first one would be 2 over 1 equals S over root 3. And then once I have S, then I'm going to use this side and this side to cross multiply and go from there. So let's start with this proportion right here. S times 1 would just be S equals 2 times root 3 would be 2 root 3. And then that's it. That was simple enough. There's nothing with the S, so I'm done solving. And now I'm going to go ahead and solve for T. Now, if you try to cross multiply here, you're going to end up with two variables. It's a big mess. So let's go back to 2 over 1 and then t over 2. T times 1 would just be t equals 2 times 2 would be 4, so t equals 4. And then that is it. We're just cross multiplying and then dividing wherever we need to. So taking a look at this next one, notice it's a 30, 60, 90 again. I'm going to go ahead and take a minute and see if you can fill out what do you think would go at the top of this chart. We know the bottom's going to be 1 root 3, 2, because it's a 30, 60, 90, and then just fill in your chart from shortest to longest. So x would be the shortest. I know 6 is the biggest because it's the hypotenuse, which means that w would go right there. Now, in this particular problem, I'm going to have to use this one twice. So now I'm going to do this way. It doesn't matter if I do x or w first. It really doesn't matter. But I'm just going to use those two that are next to each other. So 2 times w would be 2w equals, cross multiply, 6 times root 3. Now, I don't want 2w, I just want w. So ask yourself, if you have 2 times w, well, you would just divide by 2. And remember, that's what's out stays out. So once you take out 6 divided by 2, that would just be w equals 3 root 3. That's it. Okay, now I have w, I need to get x. So I'm using this 6 over 2 again. So now I have this one and this one. I'm going to go ahead and cross multiply. So x times 2 would be 2x equals, cross multiply that, so 6 times 1 would be 6. And if 2x equals 6, divide both sides by 2, x would equal 3. And that's it. So the key thing on these problems is figuring out what chart are you going to use and then cross multiply and divide. I'm going to give you a few minutes. We'll pick up in the next video for you to look at some of these problems and ask yourself, what chart would you use? Now, we're not going to look at all of these. We're just going to look at these first 4. I just had some extra examples on here. But I want you to go ahead and take a look before we start in the next video. What chart would you use on each of those